Hello class. In this video I will show you how to use the Windows command prompt to get information about the network that your computer is connected to, as well as do some troubleshooting of that network if you happen to be experiencing some problems. I'll present the most common commands, which are ipconfig, ping, traceroute, and nslookup. So to start, we need to open a Windows command prompt. And to do that, it's a little different on each operating system. I happen to be using Windows 7. I'm going to click on the Start orb in the bottom left corner of my desktop and then type in CMD and enter. And that launches a window. And then from here, I'm going to type in the command ipconfig. And then I'm going to use a switch, so I'm going to space/ALL, and the all switch basically gives me all the information about my computer's adapters. And the information that I'm most interested in is, of course, the adapter that I'm actively using right now to connect to the internet, which is my wireless LAN. LAN stands for local area network, my wireless LAN adapter. And on the list here, the information that is most important to me to collect is the IPv4 address, which is 192.168.1.111. And then under that is my default gateway. And that gateway is 192.168.1.1. Now this gateway is my wireless router. It is the way in which I get out of my home onto the internet. And the address that I am currently using for my computer, again the 191.168.1.111, this is an address that I've been actually given by the default gateway or my wireless router. And to sort of illustrate that, I can see that the lease was obtained on Saturday, May 3rd, and it will expire on Sunday, May 4th. So that's how long I will have this 192.168.1.111 IP address. Now, when it expires, I may actually get the same address back at the next issuance of a IP address. The function of the DHCP server, that's the Dynamic Host Configuration Protocol server, is to give out those IP addresses. So if someone comes to my house and they want to use my Wi-Fi adapter to get onto the internet, then my gateway server, you can see it's the same address as the DHCP server, will give them an address that they can use in order to get onto the internet. The next piece of information I'm collecting is the domain name system servers, and I have a whole list of these servers right here, and these servers do the job of resolving the domain names that I might type into my whatever internet browser I might use. So for example, if I were to use my internet browser to go to www.cnn.com in order to get some news information, then these servers would do the job of looking up that domain name and then giving my computer the IP address that it would need in order to send packets over the internet to talk to the CNN.com server so that I can download information from that server. Okay, so for now, that's all I'm going to need as far as collecting information. I'm going to clear the screen, so I'm going to type in the command CLS and enter, and that clears the screen, the command prompt screen off. And what I want to do now is to run a ping. The ping allows you to send a signal to another device on the network to test whether you can actually reach it. The way that the test works is it sends 4 small data packets making what's referred to as echo requests of the destination device and then getting back the echo response. And again, this tests the reachability, the stability of the connection to that device, and the speed of the connection to that device. So I'm going to type in ping and then space, and then I'm going to actually type in the IP address of my wireless router because it's the closest. So I'm going to do 192.168.1.1. Again, that's the IP address of my wireless router. And then it's going to come back and it's going to show me the reply that I got from that device. So again, let's read the information. So I'm pinging 192.168.1.1 with 32 bytes of data, and I'm doing this 4 times. And here's my reply from the device and how long it took for it to reply, 4 milliseconds. And the second packet that I sent, again, another 32 bytes, it took 1 millisecond, and the third and the fourth. And then down at the bottom, it gives me some statistics. It says that I sent 4 packets, I received 4 packets, and I lost 0. So essentially, this shows me that I have a stable connection to my wireless router. So if I were experiencing some communication problems to get onto the internet, and I find that I was actually dropping packets in this test, then it would actually indicate that the problem resides locally with my wireless router. In this case, I'm seeing that I have a stable connection to my wireless router. So I'm going to do a CLS to clear the screen. I'm going to do another ping, and this time I'm going to ping the University of Michigan's main web server, and that would be at the domain name www.umflint.edu. Okay, and again, let's look at the information. So first, it shows me that I was pinging 141.216.10.36. That's the IP address of the www.umflint.edu server. And I was sending 32 bytes of data to it. I did it 4 times. Here's the response from, or the reply from that. It took 47 milliseconds. The second time it took 50 milliseconds. Then it took 69, and then 82 milliseconds. So again, if I look at the statistics down below, it says I've sent 4 packets and I received 4 packets back. I did not lose any information from that. So this again shows that I have a stable connection to that device, and that of course the time that it took was longer because it's further away from my computer. I'm going to do one more ping, and this one is going to be a ping of an address. I'll just make this address up. All right, 192.200.25.1. And it's timing out, so it's not able to reach this device, which of course I just made up the IP address. It doesn't necessarily exist. So this shows that with those 4 test packets, that 4 were sent, 0 were received. So I got back an echo of 0. So I lost all 4. That's a 100% loss, which means that I have no connection to this device over the internet. And so this sort of shows the opposite end, showing me that I cannot reach the device at all. I'm going to go ahead and clear the screen, and we're going to move on to the trace route command. The trace route command allows you to see sort of a step-by-step route that a data packet takes on its way to a destination that you specify. So for example, if I sent a packet to google.com, before the packet actually reaches google.com server, it will travel through a number of different routers on its way. These are also called hops before it finally reaches the google.com server. So let's go ahead and do a trace route. That's TRACERT space. And then the name of the device is google.com that I want to trace. Okay, so the trace is complete, and let's go back and take a look at what we've learned from this. First of all, we're tracing the route to google.com. The particular IP address is this 74.125.225.129. So that's the IP address that was resolved by the DNS server for google.com. And I sent 3 packets out to it, and it shows how long it took for each packet basically to get echoed back on its way to this first hop. So the 3 packets each took 1 millisecond to echo back, and this is the router that they hit, which is my wireless router, 192.168.1.1. That's my router. And again, the time that it took for those to echo back was fairly short because the router is, actually inside my house with my computer right now. The next hop that was hit, it took 10 milliseconds, 15 and 11 milliseconds, and it went to 10.158.224.1, and that is a router that's somewhere outside of my home. It's probably someplace perhaps local to my street that I'm on, and it's probably something that is either shared by other internet service providers, but I do use charter.com. That is the internet service provider that I have, and as you look at the third route, or the third hop along the route, you see I have Saginaw, Michigan, charter.com. So this is the, again, the third hop along the way. This is how long it took for that router to echo back the 3 packets. And then we continue along. We have a number of charter Michigan connections, and then finally we find that we're getting outside the charter system. We're going to some what we call gateway or rather border gateway routers, and 209, so there's a couple of border gateway routers. And then finally we're arriving at some network router. This is the router that Google.com is using to respond to my request for an echo. So again, this shows that I had 12 hops along the path. That means there were 12 different routers that I hit as I asked for these 3 packets to be echoed back to my computer. And I can see, for example, if I have very large delays somewhere along the line, let's say at route number 8, if I had large delays, then I would have some idea of where along the path there might be some problems with connectivity. And in this case, 8 belongs to charter, so there'd be an issue with some charter routers along the path that could be causing me some problems if I'm having difficulties using the internet. Okay, I'm going to go ahead and clear the screen. And the last one we're going to take a look at is a command called nslookup. And what this command does is it fetches the DNS records. Again, DNS stands for Domain Name System. It fetches the records for a given domain name or its IP address, whichever I use. So if I type in a domain name, it fetches the IP address. If I type in the IP address, it fetches the domain name. And again, what the domain name system does is it's like a telephone book where it matches up a telephone name or telephone number with a telephone's name, a person's name. So if I were looking up some business like A1 Glass, then I would look that up in the phone book, and then across from the name of A1 Glass would be its telephone number. And that's essentially what the DNS domain name system does, is it resolves between IP addresses and domain names. So I'm going to go ahead and start off by doing a NS lookup of, let's do umflint.edu, and it comes back. And first, the thing it tells me is who gave me this information. So this is the information telling me which domain name system server supplied me the information. And it looks like it's a Bay City, Michigan charter server that did this for me. Its specific IP address is 24.247.24.53. And the answer that came back with was that uofmflint.edu, the domain name, is actually known by any of these IP addresses. So there are multiple IP addresses for the same domain name. And of course this makes sense because most large institutions or businesses are going to have multiple servers that allow you to connect to their information, and to handle the traffic they have multiple servers, and they simply load balance the amount of traffic on each server so it's all about the same. That way you get good performance. I'm going to go ahead and clear the screen. And the next one I'm going to do is I'm going to actually type in a address this time and then figure out what the domain name is. So I'm going to do an NS lookup, and I'm going to type in 141.216.116.122. And when I do that, it comes back and tells me, again, this is the server, the domain name system server that gave me the information, and this is the information that I got. It's a mail10.umflint.edu. That is the domain name. So what this is it is a mail server for the University of Michigan Flint. So as an example, if you wanted to get information on, from your web, as far as emails, what you could do is you could actually type in this address 141.216.116.122, and it would take you to the U of M Flint mail server. Let's go ahead and do that real quick so you can see how that works. I'm going to have to shrink my web page down here. Okay. So again, I'm going to type in this IP address in my locator window, and that's again 141.216.116.122. And sure enough, it takes me to the login screen of the University of Michigan Flint's webmail server. Okay, so that's pretty much it, and hopefully these commands make sense to you. I don't actually have any plans for an assignment here. I just wanted you to view these and be familiar with what each one of these do. They'll be asked on the quiz at the end of the chapter. Thank you.